11th May Geeks or Geeks question, kth largest sum of contiguous subarray. So we are given an array and a value of k. We have to find the kth largest subarray sum across all possible subarrays. So what are all possible subarrays? Let's say 2, then 2 6, 2 6 4, 2 6 4 1, then 6 6 4 6 4 1. These are called subarrays. You cannot delete any element from between. Like 6 1 cannot be a subarray. It would be a subset if they are asking, but it is not a subarray. So there is no possible way of doing this question without generating all the sums of all subarrays, right? So you have to generate them, and the most optimal way to generate these is n square only. You have to first create a prefix array. This is the prefix array of this array, and then you have to find all subarray sums. Like how? So 2 minus 0, 8 minus 0, 12 minus 0, 13 minus 0, then you do 8 minus 2, 12 minus 2, 13 minus 2, then you do 12 minus 8, 13 minus 8, then 13 minus 12, right? So this is the way to generate all possible subarrays. Now the only thing to consider thinking in this question is that what do you do after this? The naive approach would be that you can sort the entire array, this one, the subarray, all sum you store in an array, and then you sort it, and then you return the index plus the third, right? They are asking, so you return this minus 1. I mean the element stored at second index. That's what you return. But that would lead to complexity of log and then the value of the size of this subarray. Size of this new array that we generated, right? But whenever in the question it is given kth largest or kth smallest, and you have to sort the entire array, you always think of what? Priority queue. And whenever you're given kth largest, you think of mean heap, and whenever it is given kth smallest, you think of max heap. Why so? Because when you use kth largest and when you use mean heap along that, your answer will always be on the top of your heap. But if it is given kth largest and you try to use max heap, then you will have to maintain n minus k elements into your max heap, and also when you want to return the answer, you have to delete all the previous elements and your answer would be at the bottom of max heap, right? So that is not so optimal. So we use mean heap always whenever the kth largest is given. And here the complexity reduces to log k, because at a moment we are only trying to sort k element, or you can say at max k plus 1 elements, and that is near to k. So the complexity reduces to log k rather than the log then size of this new array. All right. So here I've given the mean heap representation. For example, you insert first 3 iterations. So 12, 8, 2, the mean heap, in the mean heap, the minimum element is always on the top. So here 2 is at the top. And then I added 13. So 2 is replaced by 13, why? Because the size of the mean heap now increased. When you insert 13, it would be 13, 12, 8, 2. And whenever it increases beyond k, beyond 3, so we pop an element. So we removed 2. Then 6 added, so no updation. Then 10 added, so 8 got replaced by 10. Then 11, then 10 got replaced by 11, and then we continue with 11 because there is nothing greater than that. So we return the 11, the third largest sum across all subarrays. So the approach is priority queue. You have to generate all possible subarray sums and maintain k size priority queue, that is nothing but mean heap, and return the top element. The complexity for generating subarrays is n square, and for the priority queue is log k. The space complexities of n, one for the heap as well as for the prefix array. So let's code this. First, let's define our prefix sum. Prefix of array dot size plus 1. You can also do without plus 1 actually, but I like to generate prefix sum like this. Then initialization. Prefix of I plus 1 is equals to prefix of I plus array of I. So this will generate our prefix array. Then we will require a priority queue, and we require a mean heap, so we have to write this. By default it is actually a max heap in C++. So this is our priority queue. Now let's generate all possible subarrays. So we will insert pq.push prefix of j plus 1 minus prefix of I. And in case our size of the priority queue exceeds k, then we will pop an element. And we return pq.top. This is the same for loop, right? I've written all the iterations here. You can refer to them. And it is passing the test case. Let's try to submit. And it is passing all the test cases. All right. So that is it. Thank you.